Okay, a very good morning, everyone. Dr. Amarnath, Assistant Professor from the Department of Communication. As we are going today, we are going to discuss a very important topic that is water purification. As of like everyone should know about this topic as this wonderful topic in the community medicine sector. Okay. So before going, I just want you to answer for these questions. The first question is, what's the most undesirable metal in drinking water? Option A, iron. Option B, copper. Option C is zinc. And option D is lead. So what's the answer for this question? So answer for this question will be lead. Lead is the most undesirable metal in the drinking water. Okay. So can you answer for this question, which is related to this topic? That is, which is the purest water in nature? It's river water, rainwater, deep level, deep well, or impounding reservoirs. So what's the answer for this? The answer is rainwater. Rainwater is the one of the purest water in nature available. Okay. The next question is criteria for safe drinking water. Option A, pH level 6.5 to 8.5. Option B, fluoride 0.8 gram per liter. Option C is nitrate 0.2 gram per liter. And option D is solids 12,000 milligram per liter. The answer for this question will be it is the pH, which is 6.5 to 8.5. So these are will be covered in the previous lectures for the water, which is okay. As we are moving for this today's topic, by seeing this picture, you can get an idea what's the topic for today. That is, you can see water is boiling in a stove, or water is getting filtered, or some chlorine tablets you can see tablets. So the topic for today will be water purification, which is very important for all the undergraduate students to know about water purification in community medicine. Okay, so we are moving to the topic, which is 100% pure. I already told you by seeing this MCQ, we are not rainwater, which is 100%. There is no 100% pure water available. Okay, only the purest form of water it is available. Okay, now what is the water should be? It should be safe and wholesome water. Okay, it should be free from pathogen agents and it should be free from harmful chemical substance. And it should be pleasant to taste and usable for domestic purposes. The water should be safe and wholesome water. Okay, it should be free from pathogenic agents, harmful chemical substance, and it should be pleasant to taste, and it should be useful for domestic purposes. Okay. So next thing, purification of water. Purification of water is of two types. Purification of water done on large scale and purification of water done on small scale. Okay. So first we'll see purification of water on large scale means what is the example for the big industries, for a big community, for large sectors of people. For this, we'll do large scale of purification. Small scale will be done in household. Household things are for a strainer like that. Okay, so mostly for the household you use small scale purification. Okay. So large scale purification. Large scale purification this depends on two things. One is the nature of the raw water. How you do it's depending on two things. One is the nature of the raw water. Water we are taking from the river or from the reservoir or from the surface water or whatever. Okay. So how the nature of the water is there and what is the standard quality of water? Water which we are taking for the purification, the nature of the water and what's the standard of water quality. So it depends on that we'll have purification. For example, if you're taking groundwater, it's no need of any treatment required right, other than disinfection, whether you put chlorine tablets or something. So groundwater doesn't need much purification techniques. But other than that, if you're taking surface water, what's the example for surface water? You're taking from any lakes or ponds or river, okay, which will have more impurities, right? When compared to groundwater, groundwater will have less impurity. So surface water will have more require more extensive treatment. That is, it requires more purification when compared to ground. Okay. So what are the components of large scale purification? It has three components. One is storage, another one is filtration, another one is disinfection. First is storage, another one is filtration, another one is disinfection. Okay. So these are the three components for the large scale purification. What is storage? Storage should be where you store the raw water. First you store first where you take the water, whether from the natural reservoir or from the artificial reservoir. Purification means like if you are storing the water, 90% of the suspended impurities which settled out by gravity, right, in 24 hours. If you are storing the water in any container or in any tanks, 90% of this impurities which is present in the surface, we can settle down by the gravity in 24 hours. Chemically, what will happen? This aerobic bacteria, okay, that will oxidize this organic matter which is present in the water and that will get oxidized this organic matter. And then ammonia which is present in the water will be converted to nitrates. Okay. These are the chemically that will happen in storage. And what will happen biologically? If you are storing the water for 1 week, okay, 90% of the bacteria will die out in 5 to 6 days. These are the things will happen. Storage. Okay, if you are storing your water properly, storage will happen. 90% of the impurities will get settled down. Aerobic bacteria will oxidize the organic matter. So from ammonia which is present in the water will be converted to nitrates. And biologically, what will happen? 90% of the bacteria will die out in 5 to 6 days. Okay. So they're helpful in storage. What is next step? That is, what is the next step? Filtration. After storage, it is filtration. So filtration, what will happen in filtration? 98 to 99% of the bacteria along with the impurities and gets removed in filtration. This filtration is of two types. This is a very important topic for undergraduate students. That is two types of filtration. One is slow sand and biological filter. Another one is rapid sand and mechanical filter. These are the types of filtration. Basically asked in 10 marks or 5 books for you. Okay. So first you are going to see filtration, that is slow sand or biological film. This consists of elements, four elements. One is supernatant water, another one is bed of graded sand, another one is under drainage system, and next one is system of filter controlled barrel. Okay. So these are the four elements. One is supernatant water, another one is bed of graded sand, another one is under drainage system, another one is system of filter controlled barrel. Okay. So this is the slow sand filter or biological filter. Here you can see, I already told you, this is the supernatant water. Supernatant water. What is the next one? That is sand bed. Okay, this is the sand bed. Okay. And after that, what is the next element? That is under drainage system. Drainage system. Another one is what is another one? This is a filter control. Whereas filter control. Okay. So here supernatant water, and down will be sand bed, then on the under drainage system, and then filter control valve. Here the water will get filtered and it will be ready to drink and for the next process. Okay. So this is what this is the slow sand filter or biological filter. Okay. We'll see each and element in detail. First one is supernatant. Supernatant water will be present where? It will be above the sand bed. How much deep? It will be 1 to 1.5 meter deep. And then it will give constant head of water. That is constant head of water to overcome the resistance. That is, it will give constant pressure to the sandbed. If you give constant pressure to the sandbed, what will happen? The filtration will takes place from the sand. Okay. Here, the waiting period for the partial purification will be 3 to 12 hours, where there will be sedimentation, oxidation. Okay. All this process will take place in 3 to 12 hours. That is supernatant water. The main thing is it will give constant pressure to the sand bed. Okay. The next one is we are going to see is sand bed. Sand bed, it is the most important part and its thickness is 1 meter. And then sand grain. What is the so this is one of the important things when you are talking important difference when you are talking about the slow sand filter and rapid sand filter. It is the sand with grains effective diameter. Here it is 0.2 to 0.3 mm. Okay. This sandbed is very clean and it should be free from clay or organic matter and it will be supported by a gravel layer of 30 to 40 centimeters. I will tell you where it is. And then what is the next important difference is filter. how slow it will be like 0.1 to 0.4 meter cube per hour per square meter. Filtration takes place. What are the process here? Purification process, mechanical straining, sedimentation, absorption, oxidation, and bacterial action. These are the things will happen here in the center. Okay. The two things it is effective diameter is 0.2 to 0.3 mm. And then I have talked about the filtration is 0.1 to 0.4 meter cube per hour per square meter. This is the difference between the slow sand filter and rapid sand filter that will be seeing later. Okay. So this is the, I told you, is supernated water. This is the sand bed, which is supported by a gravel layer of 30 to 40 centimeter. The sand bed where the surface diameter is 0.2 to 0.3 L. Okay. So this is the under drainage system. Okay. And now it's clear. Sand bed and it's supported by a gravel layer. That is sand gravel layer along with the deep conditions of sand bed. Okay. So this is about I have told. So the sand, but I have told you, it won't be like the same diameter. So there will be fine sand, there will be a coarse sand, and gravel layer also will have a fine gravel, then it will have coarse gravel like that. Will have the main layer of like a sand like layer, it will have for the sedimentation process. Okay. So then this should be very clear. So we go to the next. Next one is vital. If we talk about what is vital layer, it is a surface, it's vital layer which is present on the surface of the sand but is still covered by a layer that is vital layer. It is also about the slimy growth. It also see how this vital layer is formed. There is a slimy growth, that gelatinous growth which consists of algae, plankton, diatoms, and bacteria, which is known as how to pronounce it. This is smudge thick layer or vital layer, a zoological layer, a biological layer, over we can tell. But the main thing, it is a smudge decay layer. Okay. The formation of this vital layer, it is called as ripening of this filter. Simple. When the filter is first formed, right? The filter is first formed, it's frozen filter is first formed, there won't be any vital layer will be present. So what will happen? It will just act like a mechanical stain. Just for the water, so in water, then there will be a absorption of water. Only partial purification will take place because it will just act as a mechanical stainer. After this form of this much decay layer, that is zoological layer, which consists of algae, plankton, diatoms, and bacteria, this will become the important part. That is the ripening of this filter. Okay. So then the filter will get under for the filtration process. When the filter is ready for this filtration, this layer will be 2 to 3 centimeter. Okay, this layer is a very thin, slimy layer, 3 centimeter, and which is called as the heart of this filter. Heart of this filter is called as smudge decay layer or vital layer. What it will do? It will remove this organic matter, hold back the bacteria, oxidize this ammonium nitrogen into nitrates. Okay. In storage part also, then there's the PM get converted to nitrates. Here, the main part, you will oxidize all this ammonium resin that are converted into nitrates. Okay. What's the next thing? After this vital layer, so this I already told you. This is the vital layer that will be 2 to 3 centimeter that will form over the surface of the sandbed. Yeah, you can see this is formed in the whole surface of the sandbed. That is smudge decay layer. Okay, smudge decay layer. Okay, then there are any doors? Anything? Okay, in the next layer. What's the next thing? Which is under drainage system. What's the next thing? That is under drainage system. Till now, what are we have seen? Give a clarification for you. Till now, it stores and filter. What are the things we have seen? What are the four elements? That is supernatant water, sandbed, under drainage system, and filter valve. So we have covered this supernatant water, then sandbed. Sandbed, it consists of an important layer, which is vital layer or smudge decay layer. Till now, we have covered. Okay. After the next, what's the third one? That is under drainage system. So now we are going to see under drainage system. It is the bottom of the filter bed. It consists of the filter pipes for the filtration of the water, outlet for the filtered water, and it supports the medium. Okay, there's another one thing called filtered box. Filtered box which is 2.5 to 4 meter depth. Okay, it is made up of walls of bricks. It is made up of bricks as well. Okay, what the filter box consists of? It consists of supernatant water, sand bed, gravel layer, and filtered water. I'll tell you what it is. This sauce this is what we call as filter box. Okay, it has a supernatant water, sand bed, gravel layer, and other layer system. So this is how they'll make. They'll make of bricks and cements. Okay, this is the filter box. The first three elements will consist of this filter box. Okay, they call this filter box. Okay, it is 2.5 to 4 meter depth. Okay, consists of filtered water for the flow of the filtered water. Okay, and it also what sunrise systems help. It help the support the medium. Okay, above medium. Next one is the last element is filter control valve. The valve that device the outlet system. I can see this is the valve of the outlet system. Okay, it will maintain this filter control valve. So obviously it will control the valve, right? So it will control the constant rate of filtration. The constant rate of filtration will be controlled by this filter control. And there is a venturi meter will be there, which measures the pressure or resistance. Sorry. Or the loss of head or pressure measured by this venturi meter. When the pressure is goes up, the pressure is built up, then there will be opening the valve. So the water will get filtered. Water will get constantly filtered again. When this pressure is goes more than that is the loss of it is goes more than 1.3 meters, and then it will be uneconomical to run this filter or because there will be more of dust. Uh, there will be more pressure will be built up more than 1.3 meters, then it will uneconomical to run this filter. Okay. What will happen then? When there is an economical, we cannot throw that filter, right? We cannot throw this. What we have to do? Clean the filter valve. Okay. So next one is cleaning. How they will clean. Okay. Right. Cleaning. Cleaning this filter will be run for a week or more without cleaning. When there is, as I already told you, and the system the resistance increases more than 0.3, that we fully complete the bath, then it is time for the filter to clean. The supernatant water will be drained off. The sand layer with the sand layer they will be cleaned by scraping the top layer, top 1 to 2 centimeters of the layer will be done by scraping. It will do scrapping. Will be done by unlayer skilled labor. Skilled labor also can do this. Just scrapping. If you are doing 20 to 30 times of scrapping, like one time scrap, you'll do one time scrapping, then one time cleaning, then it will run for a week, 7 months. Then again you have to scrap. Like that, if you're doing for 20 to 30 times, then the bed, you have to measure the sandbed layer. If it is comes to 0.5 to 0.8, then thickness of sandbed is present. Then it is time for the fan to close. Then you build the next close it. Okay, see this is how they clean. Just scrap the layer onto one face, 2 centimeters is done by skilled labors. So like this, you'll have one, two, like that, you'll have more fluorescent filter. If this is runs for for 20 times of scrapping, then the load off and it will dismantle, then they will run again. So like that, they'll have more when water is going to and close for one, they will start again the next thing. So this is how they'll clean the fluorescent filter. So what is the advantage? It's simple to construct. It is very cheap. And the main important thing, what is the main important advantage is the quality of water is very, very high. Like total bacterial count will be reduced by 99.9 to 99.99% with the fluoride. So quality of water will be very high. So that is, and is also simple to construct and cheap. What's the disadvantage? The rate of filtration will be more, and it is the rate of filtration will time to fire for filtration will be more. Okay. So time for some relaxation. So what's the answer for this question? Slow sand filter, the element responsible for yielding bacteria-free water is option A, filter bulb, option B, wider layer, option C, supernatant water, option D is under drainage system. So answer? The answer is B, wider layer. Okay, option B, wider layer. So next we are going to see rapid sensing. See, in the components of large-scale purification, we have seen storage, filtration, and disinfection. So in this class, we are mainly going to talk about the storage and filtration. So disinfection will take after stress. Okay. So for storage, we already done. Filtration is of like slow sand filter and rapid sand filter. Slow sand filter is done. Now next thing, the important thing, that is rapid sand filter. In rapid sand filter, we have two types of two types. One is gravity type, another one is pressure type. Okay, gravity type, you have better sense filter, and pressure type, which is Candace filter. Okay, here the steps involved is four steps. One is coagulation, another one is rapid mixing, next one is flocculation, another one is sedimentation. All the steps will be involved. Then the water will be taken to the filter where it will get mixed, where it will get filtered. Then chemical disinfection will be happening. Then it will be ready to drink. Okay. So we'll see in everything in detail. Okay. This is rapid sand filter. Okay, we'll see everything in detail. So rapid sand filter. This is what we again will see in detail. Okay. So see what will happen here. This is very important for diagram for this rapid sand filter. Okay. So here from the raw water. Okay, raw water. Whether some we can take storage, but mostly the difference here is there is no much storage of time required for this rapid sand filter. In slow sand filter, we have to store the water, then we have to send the water for the slow sand filter. Here the difference is in balance sand filter, there is no storage or stream. We can take the water directly from the raw water from the surface of the lake river, and then we have to add some alum. Alum, that is alum we should add. The dosage of alum depends on the nature of the water. If it is more impure, you have to add more alum. If it's less impure, add less alum. It depends on the nature of the water, we'll add alum. Then in a mixing chamber, we'll just mix for 30 minutes, then mix this alum along the raw water, just mix for 30 minutes fastly. Then next it will be sent into the flocculation chamber where there is small stirring of water or another water. First, okay, 1 to 2 hours, there will be small stirring of water, and then a flocculation will form. After that will be sent into the sedimentation tank, where it will taken for 2 to 6 hours for a sedimentation, where 95% of the sedimentation of the flocculation of the utilities will get settled down in the sedimentation tank. Then it will go to the sedimentary filters. There are some filter where you get current gets filtered. Then after being filtered, chlorine, that is, chemical recipients will be added. Then it will go to the clear water storage and be used for consumption. Okay, these are the things for the rapid sand filter. So first is cleansing chamber, next one is flocculation chamber, then it goes to sedimentation tank, filters, then it will be for the clear water storage for consumption. Okay, then next one. As I already this is steps. The first one is coagulation. That is raw water along treated with alum. Initial dose depends on 5 to 40 mg per liter, depending upon the turbidity, color, pH, and temperature of the water. And then rapid mixing, mixing that will be rapid mixing in the mixing chamber. That is raw water along with the alum. And then flocculation, flocculation stores staying in a flocculation tank for 30 minutes. The formation of a thicker hydroxide will be formed. Then in sedimentation tank, it will allow for 2 to 6 hours. Then flocculation presented along the impurities will get settled down. Then this partially clarified water is now subject to the rapid filtration. Then after that, what will happen? After the filtration, the chemical disinfection will be added. Then it will switch to the clear water tank for the consumption. Okay, this is step in rapid sand filter. Okay, here everything is the same. The particular main differences, the certain medium sand is filtered the same as that. Here, the effective pore size of the sand size will be 0.4 to 0.7 m. There it will be 0.2 to 0.3. Here it is 0.4 to 0.7 m. Okay, that is friends. Another one is the rate of filtration. There it will be 0.1 to 0.4 meter square meter cube, meter cube meter square per hour. Here it will be 5 to 15. It's not 0.1, it is 5 to 15 meter cube meter square per hour. Okay, that is the rate of filtration and effective size will be different between the slow sand filter and rapid sand filter. Okay, and what will happen in the filter between this is a rapid sand filter? See what will happen. The aluminum floccule, which is not removed by the sedimentation tank, it will held back on the sand bed and it will form a slimy layer compared to the zoological. What is the zoological layer? That is much thicker layer. That is a whiter layer present here. Here there is no whiter layer present here as soft like the small sand filter. Instead of that, what will happen? This whatever the aluminum floccule which is formed in the flocculation chamber, which is not removed by the sedimentation tank, that will hold held back this sand bed and that forms a slimy layer which is comparable, not the same thing, but it's comparable to the zoological. Okay. So that will absorb this bacteria and oxidation of ammonia to nitrates. Okay. Here the loss of heat from there it will be more than 0.3 meter. Here it will be 78. It will be holding up to 78 feet. Okay. So how they'll wash here? That they'll be in slow sand filter. How they'll wash? They'll wash by scrapping, right? They'll wash by scrapping off the sand. But here they'll wash by backwashing. And then another difference is there we need weekly or monthly washing. Here we need daily washing or weekly twice like that washing. How they'll do backwashing? Backwashing means by reverse flowing of the water. Okay, reverse flowing of the water. Okay, reverse flowing of the water by reverse flowing of the water. Then wash this tank, that is a filter. It will take clean crystal. Okay, what is the advantage here? It can directly deal with the raw water. In slow sand filter, it can be deal only with storage of so time taken. Here it can deal with raw water directly. Another it will occupies very less space. And filtration is very rapid and washing is also very easy. There starting here, it will be required only backwashing. Okay. So this is the rapid sand filter and this is the slow sand. Okay. This will be one of the spotters in practical exam, which is one of the important spotter that is the rapid sand filter and slow sand filter. Okay. Just remember these two pictures. Yeah. So the main important question for you is what is the comparison results slow sand filter and rapid sand filter? The slow sand filter, regarding the space, slow sand filter occupies large space, rapid sand filter occupies less space. Rate of filtration already is 0.8 to 0.4 meter cube per meter square per hour. Here, the rapid sand filter will be 5 to 15 meter cube meter square per hour. Effective sand size, here it is given, but the effective sand size is 0.2 to 0.3 mm. Here it is 0.4 to 0.7 mm to 2 mm. Okay. What is the preliminary treatment here? Plain sedimentation. Here I already told you it is only plain sedimentation from the storage. Here I told you it will go to the proper channel, chemical volumes, right? I will wash. There would have been known by now. It is washed by scraping of the sandbed and it will be done by backwash. Okay. An operation it will need less skill and it is still high skill. I already told you scrapping can be done by skilled labor also. Okay, so backwashing you need highly skilled person for the washing. Removal of turbidity will be both good only. And removal of color will be fat here, it will be good here. So the main important thing is removal of bacteria. Slow sand filter acid is comes from the storage for a long time and that will slow sand slowly filter. So it removes 99.9 to 99.99% of bacteria. Why? The important thing here it has this white layer that is much thicker here. That's why it is removing this much amount of bacteria. Here it will remove only 98 to 99% of white. Not 1%. Not when compared to mono bacteria, which is best. Slow sand filter is the best medium. Okay. So these are the difference in slow sand filter and everything. So what is the effective sand in effective size of sand in rapid sand filter? In this question, can see option A, option B, option C, option D. Okay. So the answer. It gets 15 seconds time. The answer is option B, 0.5 m. Why? The effective size of the sand at rapid sand filter is 0.4 to 0.7 m. Okay, so it's between that, it is 0.5. What is the vital layer of the slow sand filter? That should have been when option A. That is much decay layer. Very good. So till now we have seen this purification of large sand, like large scale purification. Okay. But what is the component? Storage, filtration, and disinfection. Disinfection through chemical that is chlorine. We'll have another complete class for this disinfection. Okay. The next one is purification. Purification of water on small scale. For small scale means for household. Okay. So we have first one is household purification. Another one is purification of well. Purification of well also to take another things. Okay. So we'll need that is a can even there's a some also practical question also will be there. So we'll take up the so we'll see small scale we are going to see today only about the household purification of water. So household what is the best purification method, which is the easiest one. What you'll do, you'll take the water and then boil the water for 10 to 15 minutes. So it will kills this bacteria, spores or the ova is present till removes the temporary hardness of the water. Right? So, but the main thing is the taste of the water will be get altered. Okay, there is no residual protection when further protection would be there, and it can be stored in the same container where it is boiled. So, which is the simplest one is boiling the water. Even in many of the places we will do boiling of the water for the household purification. The next thing we'll do, you have bleaching water, right? Bleaching water contains how much percentage of chlorine? 33 percentage of fresh available chlorine. Okay, bleaching powder will be stored in a dark places, in a closed container. Okay, so boiling of water, the chemical disinfection what you'll use. Chlorine solution. What is chlorine solution? It will be prepared from this bleaching powder. 4 kg of bleaching powder with 25% of available chlorine mixed with the 20 liters of water, which gives 5% solution of chlorine. So this is very important. 4 kg of bleaching powder with, with available 20% of chlorine. Plus, like 4 kg of bleaching powder get mixed with the 20 liters of water. Okay, that gives 5% of 5% solution of chlorine. Okay, that will be added. Okay, that will be added to the water for the purification. Next one is high test hypochlorite, that is perchlor, which is more stable when compared to others. Okay. The next one is the most important and easiest one is chlorine tablets, that is halogen tablet. Good, but the main problem is costly. In most of the villages, they would have used this in the previous time, like in the 80s and 90s, they would have used this chlorine tablet. Even in some places, novels, they're using this chlorine tablets. Okay. Single tablet 0.5 mg, 0.5 grams, 0.5 grams, sorry, not mg, 0.5 grams is sufficient to disinfect 20 liters of water. For 20 liters of water, for water can that's a 20 liter, right? Just put one tablet that is more than enough, that is 0.5 grams of one tablet, you to disinfect 3 liters of water. Okay, this is simplest. The next one is they'll use iodine, emergency disinfection of water, just 2 drops of ethanol solution is sufficient for 1 liter of water. The main thing is contact period should be there for 20 to 30 minutes, but it is high cost and the main important disadvantage here is it is physiologically active, active. So that is a main disadvantage in iodine. Okay. The next one is potassium permanganate. It is no longer used because of it you can change the color, smell, and taste of the gas. So nowadays it is not used nowadays. Okay. Next one is in ancient time they use this filtration, that is ceramic filter. They use this chamber filter or the field filter or filter. They use this types of filter. The main part of the filter is candle. Okay, it will remove the bacteria but not the virus. Then the ancient way, this is for the drug free filter, keratin filter, okay, chamberlain filter, and drug free filter. Okay, the main thing is to remove bacteria but not the virus. But the next thing that is ultraviolet radiation. Radiation. Okay, it can destroy bacteria, viruses, fungi, algae, everything. Here, the UV rays will at the wavelength of 254 nanometer. It will be bring to the water. Water should be free from the turbidity and corrosive substance. It should be short exposure is required. Okay, no taste or odor will be changed, but there is no residual effect. What's the wavelength UV rays? 254 nanometer. Okay. No residual effect will be present. What is unfiltered irradiation? The last one, multi-stage reverse osmosis purification. What's this? RO water. So thus we are using this RO water, right? To remove the total dissolvent, solid, hardness, heavy metals, bacteria, virus from one side. Okay. Where the reverse osmosis process will be takes place. We have omnifilters, the mini filters, raw water will be into this filter, then the RO system goes to the reverse osmosis system, then it comes to the whole tank, right? Pure water tank. Okay, this is the process, then multi-stage reverse osmosis purification. So what are the things here? So in household purification, we see boiling under chemical disinfection where it contains chloride solution, chlorine tablets, iodine or potassium permanganate, and filtration in ancient period levels and filters, as an ultraviolet radiation and last one is auto purification. Okay. So what is the answer for this? The slow sand filter is differentiated from the rapid sand filter by bacteria are removed more efficiently. The cost construction is cheaper. Small, longer duration is needed. What is the answer? This thing, what's the answer for this question? Answer is all of the right. Bacteria to make it more removed more efficiently. Cost of the construction is cheaper. Sand particles are smaller size and longer duration is required, obviously. So answer is all of the above, right? That then next one is and the river water is stored for first 5 to 7 days. Bacterial count is drops by as much of 25%, 50%, 90%, 100%. What's the answer? Fast. So everyone can answer, right? Answer is 90% of the bacterial count will be reduced by 5 to 7 days. Okay? The last question. On the sorry, question number questions. The most effective water treatment method in rural places. Rural places in a rural community, what is the most effective? The answer is chlorination of water. That is option C. That is chlorination. The last question is what chlorine tablet is sufficient to chlorinate how much liters of water? The answer is B, 20 liters of water. Okay. So today we have seen large scale purification and small scale purification. On large scale purification, we have storage, filtration, and filtration. We have slow sand filter, rapid sand filter, and then disinfection. And in household purification, I have told you 5 things. Okay, these are the things we have seen today. Thank you so much for listening. Thank you very much.